So we've talked about algebraic expressions. If you remember, those are expressions that have at least one letter or variable in them. So today we're going to talk about the other type, which is the most common type. So an expression that only has numbers and operations, the most common one, is called a numerical expression. Make sure you're writing this in your notes as I'm typing this so that you have it in front of you. So a numerical expression is basically just a math problem with numbers, no letters. So I remember this because numerical starts with N-U-M, and so does the word number. So that's how I remember it. So an example of this could be 5 times 2 or 8 plus 9 times 3. So any type of math problem that only has numbers. So I want you to take a second and come up with your own example and write it here. A blank expression is an expression that contains numbers and variables, or it could be just variables. This is the one we just did the last couple of days. Algebraic. So again, I remember AL for alphabet, so that's how I remember that this kind has letters in it. So this is just vocabulary so far. So numerical has only numbers, and algebraic has to have at least one letter or one variable. So again, another example could be 6 times B, C minus K. We've done this for the last couple of days. The main difference between an algebraic expression and a numerical expression is that algebraic contains variables or letters, and numerical does not. So make sure that you write that down. So algebraic has letters or variables, numerical only has numbers. To write an expression, you use keywords to determine which operation to write. So we're going to take math problems written in words, we're going to find the keywords to figure out which operation they're talking about, and then we're going to write out the algebraic or the numerical expression. So there's a list here. You can look through it. These are just some words that help you imply certain math operations. For example, the sum of 7 and 3. So we have to figure out what's that keyword sum mean. So the keyword is sum, which means to add. Make sure you're writing this with me. So the expression would be 7 plus 3. This is what type of expression? Only numbers, so numerical. Okay, so make sure you're writing all of these down on your notes as I'm saying them. So the keyword was sum, that means to add. The expression would then be 7 plus 3. It's a numerical expression because it's only numbers. All right, let's try this one. The difference of Q and 4. So the keyword is difference. That would mean subtraction. So the answer is going to look like Q minus 4. And this is what type of expression? Algebraic, because it has at least one letter. All right, so we're going to try some of these in the big ideas. Okay, so let's take a look at this one. So this is saying write the phrase as an expression. That means they want you to write it in actual numbers or letters instead of in words. 8 fewer than 21. So the key words there are fewer than, which means you're subtracting. Now with subtracting, order matters. So you need to think of what's actually being taken away. 8 fewer than means you're taking 8 away from 21. So it's going to look like this. 21 minus 8. You don't even have to solve it. It says nowhere here to solve it. It just says write what it looks like. This would be a numerical expression. I'm just going to put NUM because it only has numbers. The next one, the product of 30 and 9. Product means times, so 30 times 9. Again, you're not solving it, you're just writing what it would look like. And again, that's also numerical because it only has numbers. So let me give you one of these to try. Okay, so you're going to pause and try these two. You're not solving them at all, you're just writing what it looks like as a math problem, okay? So try these. Okay, let's look at these ones. Write the phrase as an expression. So again, we're not solving anything, we're just writing what it looks like as a math problem. So 14 more than a number x. So 14 more than would mean add, and then they're telling you to use a number x. So x is your variable. So they say a number x because the variable represents a number. It looks weird the way they write it, but it just means put the variable. So this would be an algebraic expression because it has at least one letter. The next one, a number y minus 75. So that's going to look exactly how it sounds. Y minus 75. This is also algebraic because it has one variable, or at least one variable. The quotient, that means division, so 3 divided by z. And again, algebraic because it has at least one variable. So let me give you a couple of algebraic ones to try. See if you can figure out these two. Now again, you're not solving these. You actually couldn't solve these even if you wanted to because you don't know what the variable stands for. So you're not solving it, you're just writing what it looks like as a math problem. So try these two. Okay, now we're doing this as a word problem, and this is going to be a multi-step. So you have to look for several keywords here. So it says the length of Interstate 90 from West Coast to the East Coast is 153.5 miles, more than 2 times the length of Interstate 15 from Southern California to Northern Montana. Let M be the length of Interstate 15, which expression can you use to represent the length of Interstate 90? So make sure when it says Interstate 15 and Interstate 90, these numbers aren't being involved in the math at all. That's the name of the highway. So just keep that in mind. So let's take a look. It's saying 153 miles more than, so that tells me that we want to start by doing 153.5. More than means we're adding. So plus 2 times the length of Interstate 15. 2 times literally means 2 times. And they're telling us to use M for the length of Interstate 15. So Interstate 15, it says right here, let M be that letter. So instead of writing all of that, you write the letter M. So I have this. Now I'm going to clean it up a little bit. Instead of writing 2 times M, I can write 2M. And then I'm just going to bring this down, 153.5 plus that. So now I'm just looking, it's multiple choice. I want to see which one looks like mine. Now this addition means that you can put the 2M in the front. It doesn't really matter. You're going to get the same answer because you're doing the order of operations anyway. So that's actually going to be the very first answer to this. So that would be answer A. Okay, so let me see if I can give you a multi-step one to try. Okay, see if you can figure this one out. The number of students in the science club is 4 more than twice the number of students in the math club. They're telling you to use the variable M for number of students in the math club. So see if you can write an algebraic expression. So your keywords are 4 more than. So 4, think of what more than means. Twice the number, think of what twice means, the number of, and then you're going to use the letter M for students in the math club. So see if you can figure that one out. Okay, let's try this one. So this is going to be a multi-step. They want us to use a chart. I'm going to give you one to try just like this, and you might see one in the future. Hint, hint. So make sure you're watching this. You plant a cypress tree that is 10 inches tall. Each year, its height increases by 15 inches. Step A, make a table that shows the height of the tree for 4 years. Then write an expression for the height after T years. So they want to see if you could figure out a general formula for this. So let's look at their chart. The height is increasing, so we're going to add 15 each year. So this means the number of years and how tall it is. Year 0 is when you first bought the tree. So year 0, the tree is 10 inches tall just when you bought it. Okay? After 1 year, it's the 10 inches that it was when you bought it, plus it grew 15 inches. So now it's 25 inches. Year 2, it's the 10 inches that you originally had, plus 15 inches a year times 2 years. So you do 2 years times 15 inches a year, which is 30, plus the 10 it originally was. That gives you 40. Year 3, 10 inches from when you first bought it. 3 years times 15 inches a year is 45, plus the original 10, so 55 inches. Year 4, the 10 inches from when you first bought it, plus you're doing 4 years times 15 inches a year, so that's 60 inches, plus the 10 when you bought it is 70. So the general rule is you're taking the 10 that it originally was, and you're adding it with 15 inches times however many years. So if you wanted to figure out how tall it would be in 9 years, which is question B, instead of continuing the chart, you can just do 15 times 9 and add 10 to it. So 15 times 9 is 135, plus 10 is 145. So that's how you would solve a problem like that. This is very similar, so let's see if you can figure this one out. So it's saying it's 4 inches tall. During its growing season, it grows 3 inches a day. So see if you can do the same thing with the chart, figure that one out.